Good morning, ladies and gentlemen. Thank you. It's my honor to be here. I would like to thank Professor Yeo and Singapore University of Technology and Design to invite me here to join the symposium. I hope my presentation today will be of benefit to us all. Thank you. The topic today is 2 case studies of historic timber buildings conservation in Thailand and amphibious approach. I'm a low-tech person. Introduction. Relevance of Buddhist artifacts and buildings in Thailand have been recorded for more than 1,000 years. They have been regarded as a bridge connecting human to Buddha as well as present life to lives of outer space and time. Taking good care of them would bring fortunate lives and considered as a supreme good deed. Their status as spiritual guardians was commonly accepted. Therefore, having them restored to a former glory was a traditional idea for the protection of historic monuments. The new attitude toward ancient buildings was different. Substance was more important than spirit. International conservation consider artifacts of the past as monuments, not spiritual guardians. Their protection aims at original material, authentic documents, and faithful restoration. This was basically contrary to traditional practices, which intention was on imagined former glory, a good deed offering to Buddha. The contradiction brought about a new practice aimed at a balance between international and traditional practice. In practical conservation, many cases reveal that the result was neither traditional nor international way. The new invention shows a too simple mix of two approaches. 2 case studies in practical conservation were chosen to present the results of this awkward situation. Chosen buildings were of timber, a good representative of native and natural materials, which incompatible appearance reveal easily when coexisting with materials of different nature. Case study 1, conservation of Bangkok city pillar. This is the first Bangkok city pillar. City pillars is a sacred artifact in Thai culture. City pillars building has its roots both from local primitive belief in spiritual guardians as well as guardian gods of Hinduism. The purpose of building was stabilize power of those monarchies as well as well-being of people. The first city pillar was built in 1782 by King Rama I, the founder of Bangkok. It was situated at the assumed center of the city, only 68 meters opposite to the northeast corner of the Grand Palace wall. Prior to build the pillar, auspicious horoscope was calculated and inscribed on a gold sheet to be enshrined in the capital of the pillar. At the same time, a talismanic stone plate was made and put in the center of the bottom of the pillar hole. The pillar was made of Cassia javanica or chayapulk in Thai, with the size of 4.16 meter high and 29 centimeters in diameter. It was erected upright on the talismanic stone, and the hole was filled up. Finally, a shrine was built to shelter the pillar. This is the present Bangkok city pillars, which is different from the first one. In 1852, King Rama IV decided to rebuild the deteriorated first pillar and to have a new pillar fitted to his birth date. The new pillar, built of wood in an elaborated Thai style, was 5 meters and 35 centimeters tall, with 47 centimeters in diameter. The erection procedure followed the traditional method mentioned earlier. This is the city pillars standing alone. From 1852, the pillar has been experienced only minor repairs. In 1982, the years of Bangkok 200th anniversary of foundation, the government initiated a grand restoration program which covered a rebuilding of the whole compound. The city pillar and its shrines were included. The picture shows the pillar stood alone on its side, while its shrine was demolished first for rebuilding a new one. Fixing the position of the pillar. As an ultimate sacred artifact concerning stability of the city, the Conservation Committee decided that no movement would be allowed in repair procedure. Consequently, the pillar was fixed in its position throughout the operation. Demolition of the previous shrine made a finding that its floor level was 40 centimeters higher than the original level in 1852. This is the original of floor level in 1852, and here is the present, the previous ground level. Initial inspection and immediate remedy. An initial inspection was made after the demolition of the previous shrine. It was found that, apart from 3-degree tilting, the pillar had some cracks appear at the bottom, with a large cavity at the core caused by fungal attack. Excessive moisture was also noticed. An immediate remedy was injection of chemical preservative into the affected part of the bottom of the pillar. The active stage of repair. The active stage of repair starts when the new shrine was nearly completed, 1 year after the immediate remedy had done. This was to avoid any movement to the pillar occur if the construction was proceed at the same time of the pillar. Close-up inspection. The black and naked surface was embedded in the old floor and probably had been treated by fumigation in order to protect insect attack. Cracks on the planks appear at this level were narrow, but enough to find a hollow core inside. To stop excessive moisture, the first task to tackle was to stop moisture from the ground by providing a dry barrier for the lower part of the pillar. The conservation committee decided to excavate the ground to the bottom of the pillar, which was 1.70 meters deep, in order to build a watertight concrete pit surrounded the pillar. Review fact. When a deeper excavation was made, a worse condition appeared. From 60 centimeters to 1 meter below previous floor level, where it was dry and wet alternated condition area, the planks were widely open to reveal the fact that the pillar was composed of 6 planks of Cassia germanicus, or Shayaprik, covering the tectona grandis, or teak core, which was largely decomposed already by fungal attack. Operation at the bottom. From 1 meter below previous floor level to the bottom of the pillar was immersed with water. The talismanic stone plate was found, slip off the central position caused by the tilting. However, no insect attack was found. The pillar was lifted up 30 centimeters for pushing the stone plate back to the position and having it tied up to the bottom of the pillar. At the same time, a formwork was put underneath the pillar for building a concrete pit. Finally, the tilting was correct. You can see the different degree of deterioration. This bottom part was immersed with water because it's completely filled up with ground. It's very wet. And here is the most, this middle part is very deteriorated. You can see it's decomposed. That is because it was in the dry and wet alternated condition. So it makes the wood contraction and expansion. And the upper part is a bit better because the crack is small, because it's actually it's not buried in the soil. Drying period. When the concrete pit was set, the pillar was left to be dry out truly for 10 days. Reinstatement after the pillar was dry out. Chinklish caused the 6 composite planks open widely. The conservation committee decided to reinstate this cavity by reinforcement and grouting. Reinstatement continues. A number of teak sticks as well as stainless steel bars were inserted into the hollow core through this opening and were tied up. Then all openings were infilled neatly with teak slices. Grouting. Only one hole was left open for pouring the grout, which was composed of epoxy and fine sand. The pouring was proceeded until the pillar appeared to be immersed with the fluid. The process was started from the bottom and repeated every 1 feet higher. A steel ring band was tied around the pillar to prevent bursting. Grouting. Continue. Each stage took 2 to 3 hours for setting. After the process reached above the new floor level, the pillar hose was refilled and original soil and covered by a concrete new floor. And this is what I have said. Grouting above ground level. Grouting was continued at the above ground level with a thinner mix by injection method in order to warrant a solid core pillar. And the process was continued to the top of the pillar. After the structural treatment was finished, the decorative work began. All the existing gilding was removed and renewed. Finished. The restored pillars seen in the final stage. The old lotus leaf base was rebuilt, with new base had double tiers of octagonal lotus leaf pattern situated on the plain octagonal base, which was drawn inspiration from the original design found in the excavation. And here is my discussion. It seemed that conservation of Bangkok city pillars aim at keeping the original materials as much as possible, which was the international idea. However, the use of epoxy seemed to be excessive and unnecessary, as epoxy was not only too hard for wood, but also irreversible, and this was opposite to the guidance of International Charter for Conservation. In fact, a mix of softer and reversible local materials such as wood sealant made from Burma sole or teng resin, rubber oil, and kapok or nun in Thai fiber would be more appropriate. Furthermore, there were still some works in this case study that reveal the ambiguous nature of example. For example, on one hand, renewing gilding was a traditional practice. On the other hand, fixing the pillar position and keeping the original horoscope of the pillar calculated in the past might be a new invention. If we keep in mind that a restoration tradition for a city pillar was to build a new one that was suited to its space and times, as King Rama IV did in 1852, not to keep the material of the old pillar as much as possible. This is the second case study, the conservation of Tab-Kwan Royal House. Tab-Kwan Royal House, standing in large foliage of trees harmonious to the color of their teak material. Tab-Kwan Royal House was built in 1912 by King Rama IV as a royal resort in Sanamjan Palace compound in Nakhon Pathom, 60 kilometers west of Bangkok. The king used this palace for rest, as well as training his private force in guerrilla warfare. The house was a group of 8 houses arranged in a rectangular layout surrounding a central open court where a jan tree or Diospyros decantra was planted. As a Thai house, each unit carried unique characteristics. The frame structure was raised on stilts. The plan was composed of 2 rows of freestanding round columns, which each transverse pair was connected by a through beam. Floorboard was immediately placed on the beams. Wall panels were assembled by smaller pieces of teak. Joints were connected by mortise and tenons and fixed by pegs. Therefore, its construction was a prefabrication manner. The steep roof was covered by a kind of palm leaf called fag or Nipa fruticans, and looks remarkable by its backboards. The house was neglected after the reign of Rama VI and gradually deteriorated. This is the condition in 1982. In 1982, an action plan for conservation was set up by collaboration between Tab-Kwan University, the then caretaker, and Fine Art Department. An initial inspection found that the house was in a very bad state of decay, resulting from more than a half century of neglect. Structure of each unit of the compound was deformed and lost its upright and horizontal direction because of loosened joints. Furthermore, disappearance of roof covering caused rainwater directly pour into the houses and damaging floorboards. Wall panels were stained by mold growth and about to fall apart. The whole compound was collapsing. Fine Art Department was responsible for the conservation in 1983. Dismantling and reassembling method was used due to the bad state of decay, which seemed that in situ repair was not appropriate. The work started with taking down parts of each house piece by piece, starting from the roof to the bottom. The roof was first to taken down. Components of the roof were taken down first, starting from purlins to rafter. King posts and tie beam were left connect to the transverse pair of columns in order to retain the structural frame, which was made possible for wall panel to be taken down safely. After the king posts, tie beams, floorboards, and through beam were dismantled. Then the columns was pulled down. Freestanding columns were the final elements to be pulled down. Carpenter workshop is an important part in this conservation. Each dismantled member was orderly arranged in types and groups and kept in a carpenter workshop for repair. A new structure. The restored house would be used as a public building. A stronger bearing capacity as well as more durable material was required. This led to a change in original structural system and materials. The reassembling work started with building modern concrete foundation on piles with new concrete support. Casting new concrete support were being cast. Double tier beams. This is the process of casting the support. A new double tiers of floor beam system was introduced to replace the original single tiers through beam. In the original structure, there is only one tier of beam across the transverse pair of the columns. Now they introduce the double tiers of beams. A close-up view of double tiers floor beam system, which has never been existed in the original Thai house, was introduced, connecting old and new column. The next step was to erect the nearly 2 meter cut shutter column, original columns, connecting to the new concrete support by steel plates fastened by bolt and nut. Totally a new invention, recreating the building frame. Then the tie beams for roof structure were installed. At the same time, at this step, the separately repaired wall panels at the carpenter workshop were brought to the house and ready to reinstall. Most of these teak panels were found in a good condition. Only their skin were obscured by mold stain, which were easily removed by polishing. However, parts of some panels were redone. This have to thank the very good quality of teak. Wall panels were reinstalled by manual operation with our machinery. Then roof reassembling. After the wall panels were reinstalled, components of roof structure were followed: king posts, rafters, and purlins. Although most of the triangular frames were original, diagonal bracing were added to each king post for increasing strength enough to bear new terracotta roof tiles. Here you see the king post with this diagonal bracing. This is also a new invention. Flooring. Then the floorboard was laid. Watertight roof. New galvanized metal sheets were inserted to the roof for rainwater leaking protection. Also a new invention. The uncovered appearance. The house before painted that show contrast color between brown color of natural teak wall and gray of synthetic concrete support. In my opinion, it's quite ugly. The restore house. This is the final stage. Include roof covering in new terracotta and decorative works such as applying dark brown oil paint on the whole house and ground paved by new brickworks, which result a higher ground. Consequently, the restore raised on steel house look darker and shorter. However, it was not easy for unexperienced eyes to distinguish an original design from a disguised one. This is a fake house. Very beautiful fake house. This is important because I think conservation now include many fakes, nice things. This is my discussion. A proposed new use for the house brought a drastic change to its unique characteristic. The idea to have a greater bearing capacity building within the delicate historic timber house conveys a devastative new structural system and material to the house. The pure timber columns were replaced by disguised half concrete and half timber ones, the single tiers of through beam for flooring became double tier beams. Joining by mortise and tenons with wood pegs fixing gave way to steel nails and plates fastening. Diagonal bracing were added to king post roof frames, and finally the palm leaf roofs became terracotta tiles roofs. These so many changes for new use were not worth its loss in architectural and historic values. A more faithful conservation should have been done, although it would not have provided a stronger bearing capacity. However, this new request could be solved by a clever management, while the integrity of the house could be retained authentically. Conclusion. The two case studies show a strong attempt to retain the original appearance of the buildings, but not the materials, construction methods, and the spiritual essence of the buildings. The ultimate goal of conservation was to have practical output with an imagined former glory. Evaluation based on the international conservation idea aimed at authenticity of materials could consider both case study as a halfway success at best. On the other hand, if evaluation based on the traditional spiritual essence idea, both cases could be considered untraditional but a new invention that kept only the materialistic cover, not the spiritual core of the artifact, especially in the case of the city pillar. However, despite of having a par quality in international and traditional conservation, the practice of the two cases was able to apply to both ideas. This made it an amphibious approach, a practice that was difficult to avoid for a country of rich tradition in international conservation nowadays. Thank you.